Imagine a universe before Earth, a universe so vast and empty it's hard to grasp. No sun, no planets, just a swirling cloud of dust and gas. This is where our story begins, billions of years ago. The universe, still young, was a place of incredible violence and energy. Huge clouds of hydrogen and helium, remnants of the Big Bang, drifted through the darkness. These clouds, vast beyond imagining, held within them the seeds of future stars and galaxies. Within these swirling clouds, gravity was at work. Slowly, almost imperceptibly, it drew particles together. Over millions of years, these particles clumped and swirled, gaining mass and momentum. As more and more matter clumped together, the pull of gravity intensified. This dance of gravity and matter, played out across the universe, would eventually lead to the formation of stars, planets, and everything we know. Within one particular cloud, something extraordinary was happening. The cloud, a maelstrom of dust and gas, began to collapse in on itself. As it collapsed, it spun faster and faster, like a skater pulling in their arms. The center of the cloud, a point of intense pressure and heat, grew hotter and denser. This was the birth of our sun. The intense heat at the sun's core triggered nuclear fusion. Hydrogen atoms, crushed under unimaginable pressure, fused together, releasing enormous amounts of energy. This energy, in the form of light and heat, blasted outwards, pushing against the inward pull of gravity. A star, our very own sun, was born. Around the newborn sun, the remaining cloud of dust and gas continued to swirl. This material, leftovers from the sun's formation, would be the building blocks of our solar system. Pulled by the sun's gravity, these particles collided and stuck together. Over time, these tiny particles coalesced into larger and larger clumps. Imagine a cosmic billiards game with rocks of all sizes colliding and careening off each other. Some collisions were destructive, smashing the rocks apart. Others were constructive, merging the rocks into larger bodies. Over millions of years, this chaotic ballet sculpted the planets we know today. Section 4. From fiery inferno to molten sphere, a planet cools. The young Earth was a very different place than the planet we know today. Bombarded by asteroids and comets, its surface was a molten sea of fire and rock. The constant impacts, along with the heat generated by radioactive decay within the Earth's core, kept the planet in a molten state. As the bombardment from space gradually subsided, the Earth began to cool. The molten surface solidified, forming the first primitive crust. Volcanoes erupted, spewing gases from the Earth's interior into the atmosphere. Section 5. Oceans of molten rock, the formation of Earth's crust. Imagine a landscape where vast oceans of molten rock flowed across the Earth's surface. These oceans of magma, constantly shifting and churning, were the precursors to the continents we know today. As the Earth continued to cool, the heavier elements in the magma, like iron and nickel, sank towards the core. Lighter elements such as silicon and oxygen rose to the surface. These lighter elements combined to form minerals, which slowly crystallized out of the cooling magma. Over millions of years, these mineral crystals accumulated, forming the first continental plates. Section 6. A pale blue dot, reflections on our place in the cosmos. From a swirling cloud of dust and gas, a planet was born. Our Earth, a tiny oasis in the vastness of space, is a testament to the awesome power of the universe. The story of Earth's formation is a story of cosmic violence, incredible heat, and the relentless pull of gravity. But it is also a story of creation, of order emerging from chaos. The same forces that shaped our planet continue to shape it today. The continents drift, volcanoes erupt, and life evolves, a constant reminder of our planet's dynamic nature.